The UBC partnership started out because we were looking for a place where we could actually trial and really kind of create the roadmap around 5G applications and use cases. Smart cities is a pretty big domain. I think what we've been focused on is really kind of building up our capabilities in the smart transportation domain. What we're trying to do is get cities prepared so that they're in a position to take advantage of those technologies that are on the horizon.
I've been working in intelligent transportation for almost 10 years, and I'm really excited about the opportunities that we're having by working with Rogers. The Aurora Connected Vehicle Testbed was originally set up to solve the problems and barriers that need to be overcome in order to make intelligent transportation a reality. The ultimate goal is to improve road safety, to reduce traffic congestion, and to enhance commercial vehicle operations and efficiencies. Traditional intersections are relatively disconnected from the rest of the network. Previously, it's been too expensive to deploy this connectivity. 5G is going to make it possible to do so at a rate that makes it practical. The data flow in an intelligent transportation system is relatively complicated. The most basic level is to get information back to the traffic management center where operators can react in real time. But what 5G introduces is the notion of another alternative route. For devices such as smart sensors deployed in intersection, their signals would go to the nearest Rogers tower, going through the multi-access edge computer located at the cell site. That's what makes this ultra-reliable, low-latency computing. This means that decisions can be made in instantaneous time by automated algorithms. So the three modes of communication that our technology enables is vehicle-to-vehicle communications via the so-called side link, vehicle-to-intersection communications, and vehicle-to-network, which opens up possibilities like emergency and transit vehicle preemption. The onboard unit can be added to vehicle in two ways. For a new vehicle, it can be installed at time of manufacture. For an older vehicle, the capability can be added after the vehicle is built.
We're going to start up the terminal and we're going to start booting up some of the antennas and then we can do some testing.
Right now we're collecting positioning data from Professor Michelson in the Transport Canada vehicle, and this can be used for future safety applications like analyzing the current state of the intersection.
One of the reasons that we like LiDAR with respect to sensor technologies in the traffic management space, because we live in Canada. Sometimes cameras have a bit of a hard time in those different weather conditions. There's also an inherent privacy benefit with LiDAR that doesn't do facial detection, doesn't do facial capture, that creates 3D models versus a traditional camera which uses 2D imaging.
Traditional methods for visualizing turn indications and other activity at an intersection are designed to be printed on paper and visualized later. We're looking for a technique designed for real-time applications. So the width of the arrows would change as the number of vehicles going through the intersection changed. And as the traffic signals changed, certain indications would turn off or turn on, giving you an idea of what the traffic flows were. There's a number of ways that you can preempt traffic signals for the purposes of either transit vehicles or emergency vehicles. Some traffic intersections actually use sound sensors to hear the siren. The advantage of 5G is that you can get the intersection to send signals back. If we have LiDAR sensors at the intersection, they can assure that the intersection is clear. Research is ultimately a social activity. You need the interaction, and involving other players is essential if we want to make rapid progress. That's where we're happy that we have the opportunity to work with telecom providers like Rogers. We need to be able to validate, be able to test, demonstrate, and we need to have access to the latest hardware and the latest network. And this 5G network is really important. It's been a breakthrough that people have been talking about for 20 years, almost like fiber in the sky. So this is really exciting.